Hello everyone, and welcome back to Rebar 360. In our previous lesson, we learned the basics of reinforced concrete, the role of reinforcement, and where rebar detailing fits into the overall construction workflow. In today's lesson, we're going one step deeper. We're going to understand what rebar detailing really is, why it's one of the most important activities in reinforced concrete construction, and how it connects the design office with the construction site. We'll also learn about the people involved in the detailing process, the key components that make up a rebar shop drawing, the different types of engineering drawings used in a construction project, and finally, the standards and codes that govern reinforcement detailing across different countries. These topics may appear simple at first, but they form the foundation of every successful rebar detailing project. Whether you're preparing a footing, beam, slab, wall, or high-rise building, these principles remain the same. By the end of this lesson, you'll have a much clearer understanding of the complete rebar detailing process and the responsibilities of a professional rebar detailer. Today's topics. We'll cover: what is rebar detailing? Why rebar detailing is important. Stakeholders involved in the detailing process. Key components of rebar shop drawings. Different types of engineering drawings. International codes and standards used in rebar detailing. Each topic builds upon the previous one, so I recommend watching the complete lesson without skipping any sections. Let's begin with the most important question. What exactly is rebar detailing? Now let's understand the most important topic in this course. What is rebar detailing? In simple words, rebar detailing is the process of preparing reinforcement shop drawings and bar bending schedules, or BBS, based on structural drawings. But rebar detailing is much more than simply drawing steel bars in AutoCAD. Let's understand the complete picture. The structural engineer designs the building and decides how much reinforcement is required to safely carry the loads. Their drawings tell us what reinforcement is needed, but they don't provide all the information required for fabrication and construction. For example, the fabricator needs to know: what is the exact length of each bar? What shape should it be bent into? How many bars are required? How should the bars be tagged? Similarly, the site team needs to know exactly where each bar should be placed. This is where the rebar detailer comes in. The detailer converts the structural engineer's design into clear, practical instructions that the fabrication yard and construction site can follow without confusion. That's why rebar detailing is often called the bridge between design and construction. It requires technical knowledge, attention to detail, and an understanding of construction practices. A professional rebar detailer doesn't just prepare drawings. They ensure that the reinforcement can be fabricated efficiently, transported safely, and installed correctly on site. Even a small mistake in detailing, such as an incorrect bar length, wrong shape code, or missing bar mark, can result in fabrication errors, site delays, and costly rework. That's why accuracy is one of the most important qualities of a successful rebar detailer. Always remember this simple principle. Structural drawings tell us what to build. Rebar shop drawings tell us how to build it. And that transformation is the responsibility of the rebar detailer. Professional tip. Don't focus only on learning drafting software. First, understand the purpose of every reinforcement bar. A software operator creates drawings, but a professional rebar detailer understands the structure. Now let's look at the two most important outputs of rebar detailing. Every rebar detailer is responsible for preparing shop drawings and the bar bending schedule, commonly called the BBS. Let's understand each one. First, shop drawings. Shop drawings are detailed reinforcement drawings prepared from the structural drawings. They show exactly how the reinforcement should be placed inside each concrete member. A typical shop drawing includes bar locations, bar marks, bar diameters, spacing between bars, concrete cover, lap splice locations, sections and detailed views, notes and references. These drawings are mainly used by the site engineers and steel fixers during reinforcement placement. A good shop drawing should be so clear that the site team can place every bar without repeatedly asking questions. Second, bar bending schedule, BBS. Once the shop drawing is complete, the next step is preparing the bar bending schedule. The BBS is a fabrication document. It contains complete information for every reinforcement bar, including bar mark, bar diameter, shape code, cutting length, quantity, total weight. The fabrication yard uses this information to cut, bend, bundle, and tag the reinforcement before it is delivered to the construction site. Without an accurate BBS, the fabrication team cannot manufacture the reinforcement correctly. How they work together. Think of the shop drawing as a map and the BBS as a manufacturing list. The shop drawing tells the site team where each bar goes, while the BBS tells the fabrication yard how to produce those bars. Both documents must match perfectly. If the shop drawing shows one bar length and the BBS shows another, confusion begins. That's why every professional detailer carefully checks both documents before issuing them. Always remember, a shop drawing without a BBS is incomplete. A BBS without a shop drawing cannot be interpreted correctly. Both documents work together to ensure smooth fabrication and successful construction. Bar bending schedule, BBS. Heavy checkmark bar marks. Heavy checkmark shape codes. Heavy checkmark cutting lengths. Heavy checkmark quantities. Heavy checkmark used for fabrication. Professional tip. Whenever you complete a shop drawing, compare it with the BBS one final time. Ensure that every bar mark, diameter, quantity, and length matches exactly. This simple habit can prevent many fabrication and. Now that we understand what rebar detailing is and the documents it produces, let's answer another important question. Why is rebar detailing so important? Some people think detailing is just another drafting activity. But in reality, it plays a major role in the success of every construction project. Let's look at the 4 key benefits. 1. Avoid site mistakes. The primary purpose of rebar detailing is to eliminate confusion during construction. Clear shop drawings tell the site team exactly where each bar should be placed, reducing the chances of incorrect installation. When drawings are clear and complete, site engineers and steel fixers can work confidently without making assumptions. 2. Saves material and time. Accurate detailing ensures that reinforcement is fabricated correctly the first time. Correct bar lengths, quantities, and shape codes reduce material wastage and eliminate unnecessary rework. When the fabrication yard receives a well-prepared bar bending schedule, production becomes faster and more efficient, helping the project stay on schedule. 3. Ensures structural integrity. Every reinforcement bar has a specific purpose. Whether it's resisting bending, controlling cracks, or providing anchorage, each bar contributes to the overall strength of the structure. Incorrect detailing can lead to missing bars, improper laps, or insufficient reinforcement, which may affect the structural performance. Accurate detailing helps ensure that the engineer's design is executed exactly as intended. 4. Supports fabrication and site teams. Rebar detailing acts as the communication link between the design office, fabrication yard, and construction site. Fabricators depend on the BBS to manufacture reinforcement accurately. Site engineers depend on shop drawings to inspect the work. Steel fixers depend on detailed reinforcement layouts for installation. When detailing is done properly, everyone involved in the project works more efficiently. In simple terms, good rebar detailing saves time, reduces costs, improves quality, and prevents problems before construction begins. That's why experienced engineers often say, the quality of construction starts with the quality of detailing. As a rebar detailer, your drawings directly influence fabrication, site productivity, and the overall success of the project. Professional tip. Never think of your shop drawing as just another CAD file. Once it's issued, it becomes an instruction document for the fabrication yard and construction site. A few extra minutes spent checking your drawings can save days of rework and thousands in project costs. Rebar detailing is not a one-person activity. It involves coordination between several professionals, each playing an important role in the success of a construction project. Let's look at the key stakeholders involved in the rebar detailing process. 1. General contractor. The general contractor is responsible for executing the construction project. They coordinate all site activities, manage schedules, and ensure that the work is completed according to the approved drawings and specifications. The contractor depends on accurate shop drawings and bar bending schedules to keep construction progressing without delays. 2. Architectural engineer. The architect focuses on the building's layout, functionality, and appearance. Architectural drawings define room layouts, doors, windows, staircases, and openings. Before detailing reinforcement, it's important to review architectural drawings because changes in openings or dimensions can directly affect reinforcement placement. 3. Structural engineer. The structural engineer designs the load-bearing system of the building. They determine member sizes, reinforcement requirements, concrete grades, structural safety. The rebar detailer uses the structural drawings as the primary reference for preparing shop drawings and the BBS. Whenever there is missing information or a conflict in the drawings, the detailer coordinates with the structural engineer for clarification. 4. Rebar fabricator. The fabrication yard receives the approved bar bending schedule. Using the BBS, they cut, bend, bundle, and tag each reinforcement bar before dispatching it to the construction site. Their work depends entirely on the accuracy of the detailer's drawings and schedules. 5. Rebar detailer. The rebar detailer is the link between design and construction. They study the structural drawings, prepare reinforcement shop drawings, generate the bar bending schedule, coordinate with engineers, and ensure that the reinforcement can be fabricated and installed without problems. A good detailer doesn't just prepare drawings, they solve problems before construction begins. 6. Site engineers and steel fixers. Finally, the shop drawings are used on the construction site. Site engineers inspect the reinforcement, while steel fixers place the bars according to the approved drawings. If the detailing is clear and accurate, installation becomes faster, safer, and more efficient. The success of any reinforced concrete project depends on effective communication between all these stakeholders. When everyone works together using accurate and coordinated drawings, the project progresses smoothly with fewer errors, less rework, and better quality. Remember, rebar detailing is not just about preparing drawings, it's about connecting people, information, and construction. Professional tip. One of the most valuable skills a rebar detailer can develop is communication. Technical knowledge is essential, but coordinating effectively with engineers, fabricators, and site teams is what turns a good detailer into a trusted professional. Now let's look at the essential information that every professional rebar shop drawing must contain. A shop drawing is much more than a sketch showing reinforcement. It is a construction document that provides all the information needed for fabrication and installation. Let's go through the 5 key components. 1. Cover to reinforcement. The first component is concrete cover. Cover is the distance between the surface of the concrete and the outer surface of the reinforcement. It protects the steel from corrosion, fire, and environmental exposure while ensuring proper bond with the concrete. The required cover varies depending on the structural element and exposure conditions, so it must always follow the project specifications and applicable standards. 2. Bar size and spacing. Next is the reinforcement itself. Every drawing should clearly specify the bar diameter and the spacing between bars. For example, a note such as T16 at 150 mm C/C tells the site team to place 16 mm diameter bars at 150 mm center-to-center spacing. Correct bar size and spacing are essential for achieving the structural strength intended by the design engineer. 3. Lapping and anchorage. Since reinforcement bars are supplied in standard lengths, they often need to be joined together. This is done using lap splices. Similarly, anchorage ensures that reinforcement is properly embedded into the concrete so that forces can be transferred safely. Incorrect lap lengths or anchorage details can affect the performance of the structure, making this information very important in every shop drawing. 4. Bar shapes and lengths. Every reinforcement bar has a specific shape and cutting length. Some bars are straight, while others include bends, hooks, or stirrup shapes. These details must be shown clearly so that the fabrication yard can manufacture each bar accurately according to the required standards. 5. Bar bending schedule, BBS. Finally, every shop drawing should be accompanied by a bar bending schedule. The BBS provides complete fabrication information, including bar marks, bar diameters, shape codes, cutting lengths, quantities, total steel weight. The fabrication yard relies on this schedule to cut and bend the reinforcement correctly. Together, these 5 components ensure that the reinforcement is designed correctly, fabricated accurately, and installed efficiently. A professional rebar drawing leaves no room for guesswork. It provides clear, complete, and accurate information for everyone involved in the project. Professional tip. Whenever you review a shop drawing, ask yourself one question: does this drawing contain enough information for the fabrication yard and the site team to complete their work without asking for clarification? If the answer is yes, you've prepared a quality drawing. If not, revise it before issuing. Before preparing rebar shop drawings, every detailer must understand the different types of drawings used in a construction project. A building is not constructed using structural drawings alone. It requires coordination between several engineering disciplines. Each drawing has a specific purpose, and together they ensure the project is completed successfully. Let's briefly understand each one. 1. Architectural drawings. Architectural drawings define the building's layout and appearance. They include floor plans, elevations, sections, doors, windows, staircases, room dimensions, and finishing details. As a rebar detailer, these drawings help you identify wall locations, slab openings, lift shafts, staircases, and other features that may affect reinforcement placement. 2. Structural drawings. Structural drawings are the most important reference for a rebar detailer. They provide information about foundations, columns, beams, slabs, walls, reinforcement requirements, member sizes and levels. These drawings tell us what reinforcement is required, and they form the basis for preparing shop drawings. 3. Mechanical drawings. Mechanical drawings show HVAC systems, ducts, equipment, and mechanical services. These drawings are important because large ducts or equipment openings may pass through structural members, requiring reinforcement adjustments or additional coordination. 4. Electrical drawings. Electrical drawings indicate cable trays, conduits, lighting systems, electrical rooms, and equipment locations. Understanding these drawings helps avoid clashes between reinforcement and electrical installations. 5. Plumbing drawings. Plumbing drawings show water supply lines, drainage pipes, floor drains, sleeves, and service openings. Before detailing reinforcement, it's important to verify these openings so that the required trimming bars and additional reinforcement can be provided. 6. Civil and landscaping drawings. These drawings include site development work such as roads, retaining walls, drainage systems, pavements, and external structures. For projects involving external foundations or retaining structures, these drawings provide valuable reference information. 7. Rebar shop drawings. Finally, all this information comes together in the rebar shop drawings. These are the drawings prepared by the rebar detailer. They provide complete reinforcement details for fabrication and site installation, ensuring that the engineer's design is executed accurately. A professional rebar detailer doesn't work with structural drawings alone. They review all relevant project drawings, identify potential conflicts, and ensure the reinforcement is coordinated with every discipline. That's what makes a drawing practical, buildable, and ready for construction. Professional tip. One of the biggest mistakes beginners make is relying only on structural drawings. Before you begin detailing, always review the latest architectural, MEP, and civil drawings. A 5-minute coordination check can prevent costly site clashes and unnecessary revisions. One of the most important responsibilities of a rebar detailer is following the correct codes and standards. You cannot prepare reinforcement drawings based on personal experience or assumptions. Every project must comply with the applicable standards specified by the client or the design engineer. Different countries follow different standards, but the objective is always the same: to ensure that reinforcement is detailed, fabricated, and installed safely and consistently. Let's look at some of the most commonly used standards. IS 5525, India. In India, reinforcement detailing is commonly carried out in accordance with IS 5525, along with other relevant Indian standards. These standards provide guidelines for preparing reinforcement drawings, detailing practices, bar bending schedules, and reinforcement placement. If you're working on projects in India, it's essential to be familiar with these requirements. BS 8666, United Kingdom and Middle East. For projects in the UK and many Middle Eastern countries, the most widely used standard is BS 8666. This standard specifies shape codes, bar scheduling rules, dimensioning methods, bending requirements, standard notation. Since this course focuses on British standard rebar detailing, we'll be using BS 8666 throughout the upcoming lessons. ACI 315, United States. In the United States, reinforcement detailing generally follows ACI 315, published by the American Concrete Institute. ACI provides guidance on preparation of shop drawings, bar bending schedules, reinforcement placement details, standard detailing practices. Although the presentation style differs slightly from BS standards, the overall objective remains the same: accurate and practical reinforcement detailing. Why standards matter. Imagine two fabrication yards interpreting the same drawing differently because no standard was followed. The result would be confusion, incorrect fabrication, delays, and unnecessary rework. Standards create a common language that everyone, designers, detailers, fabricators, and site engineers, can understand. They improve communication, reduce errors, and ensure consistent quality across every project. As a professional rebar detailer, one of your first tasks is to identify which standard the project follows before you begin detailing. Never assume. Always verify the project specifications and general notes. Professional tip. One of the first things I check when starting a new project is the applicable detailing standard. Shape codes, bar notations, scheduling methods, and even drawing conventions can vary between standards. Knowing the correct code from day one helps avoid mistakes and saves a lot of time later. As we come to the end of this lesson, I'd like to invite you to continue your learning journey with Rebar 360. If you're serious about building a career in rebar detailing, structured training can significantly accelerate your progress. At Rebar 360, we offer practical training designed around real industry projects, not just theory. You'll learn how professional detailers prepare shop drawings, create bar bending schedules, interpret structural drawings, and solve real detailing challenges. Whether you're a civil engineering student, a diploma graduate, a site engineer, a CAD engineer, or a working professional looking to switch careers, our training programs are designed to help you become industry ready. If you're interested in joining our training or would like more information, feel free to contact us using the details shown on the screen. Our team will be happy to guide you on the course structure, training schedule, and career opportunities in rebar detailing. Investing in your skills today can open doors to exciting opportunities in the construction industry, both in India and internationally. We look forward to helping you become a confident and professional rebar detailer. Professional tip. Learning software is only one part of becoming a successful rebar detailer. Understanding engineering concepts, construction practices, And detailing standards is what truly builds a long-term career.